Application 5. Consider the adjacent diagram where U battery equals 5 volts and the 3 lamps are identical. This is a very important given. Given that the lamps are identical is very important. So represent the direction of the flow of the electric current in each branch of the circuit. See the figure. The current comes out of the main current comes out of the positive terminal of the battery. So you have to show an arrow here and write above it I main. Then it continues its pathway. Now we call it I1. We have to show the direction. It continues its pathway because there is no other path. Then it reaches this point in which there are two branches. It's divided between these two branches. I2, you have to show the direction, write the name. I3, show direction, write the name. Now suppose that I main is equal to 2 ampere. Determine the intensity of the current traversing each of the 3 lamps. This means that you have to determine I1, I2, and I3. In the first place, I main is equal to I1 equals 2 amperes. So this is the rule, this is the substitution. And the justification is due to the law of uniqueness of current in series grouping. Now, but I1 is equal to I2 plus I3, or you can say I main equals I2 plus I3 because I1 and I main are equal. This is the rule. What is the justification? By law of addition of current in parallel grouping. So, but L2 and L3 are identical. So because they are identical, this means that as long as I1 is additive, so the current is additive in this case, and these lamps are identical, then the current is divided equally between them. So I2 is equal to I3 equals I1 over 2 equals 2 ampere by 2 equals 1 ampere. Now 3 if the voltage across L1 is 2.5 volts, calculate the voltage across L2 and L3. You have that L2 and L3 connected in parallel. So the rule is U2 equals U3 by law of uniqueness of voltage in parallel grouping. But U battery is equal to U1 plus U2. Why did I write so? Because if we take this parallel grouping as one package and check its connection to the L1 and to the battery, we find that they are connected in series. So the grouping, not one lamp, the grouping of L2 and L3 is in series with L1 and in series with the battery. So the voltage is additive by law of addition of voltage in series grouping. Now for this grouping, the voltage of the grouping is equal to U2 equal to U3 because the voltage is unique in parallel grouping. So here I can say U battery equals U1 plus U2 by law of addition of voltage in series grouping. Then do the substitution and find that U2 equal U3 equal 2.5 volts. Now